Discuss the limits theorem of limits. Basically, as you can see that I just write one theorem, which is the limit of sum is the sum of limit. This means that if you take the limit like this, for example, if you are given a question f of x equals to 3x square plus 2x plus 2, and you have to apply limit on this function when x approaches to 2, then limit x approaches to 2, f of x equals to limit x approaches to 2, 3x square plus 2x plus 2. Now from here, this theorem, the limit of sum is a sum of limits. When our questions write in some form, then you have to take limit of each and every variable like this. The limit of constant is constant, therefore I just separate the constant from their variable. X square plus 2 into limit x approaches to 2, x plus limit x approaches to 2 into 2. Now I just put the limit in this equation, that 3 into 2 power to 4 plus 2 into 2, and the limit of constant is always constant number, therefore 2. So our answer will become 3 4 12 plus 4 plus 2 16 plus 2 18. Sorry, a mistake, 18 plus 2, and our answer will becomes 20. Now I just prove my limit that theorem number 1, the limit of sum is the sum of limit like this, that if you are given an equation that 3x square plus 2x plus 2, then you have to apply limit on each and every variable like this, that I just apply limit individually on x square, x, and on a constant number. Now I just write the second theorem. Second theorem is the limit of product is a product of limit. The same scenario happens as I discussed in the sum of limits like this, that I just take the general form, that limit x approaches to a c f of x. Now what just happened, that I just take limits on both c and f of x like this, limit x approaches to a c dot limit x approaches to a f of x. The limit of constant is always a constant, so I can write it as like this, then limit x approaches to a f of x. Therefore by applying limit on this function, we get c f of a. So our answer will becomes like this. Okay, like you just see that I just solved that. I just put limit on that constant c, and then it doesn't matter that here comes c plus f of x or c f of x. Okay, it doesn't matter, you just have to take individually limits on both. I just write two theorems at a time, that the limit of constant time of function is a constant time limit of a function like this, that the limit of constant is always a constant. In shorter words, the limit of constant is always constant. The shorter form of this theorem is the limit of a constant is always a constant. And you can see that I just write Number 4 theorem, the limit of difference is the difference of limit. Like I just told you about the limit of sum is the sum of its limit, the same scenario will be happen. I just take the general form like this, that limit x approaches to a mx minus b, like this, that m into limit x approaches to a x minus limit x approaches to a b. So limit of x will becomes m a, and the limit of constant is always a constant as I write above, b. So limit of x approaches to a, mx plus mx minus b becomes ma minus b. For more videos, subscribe to our channel Hans Innovation, and don't forget to subscribe our channels and press the bell icons to keep getting our new videos. Thank you.